Good morning, everybody. Today we are going to have an introduction to logarithms. All right, our second set of functions we're going to look at this unit. And what we're going to talk about is what a logarithm is, how do we evaluate logarithms on our graphing calculators, how do we convert between exponential form and logarithmic form, and how we graph logarithms. So today is rather a long lesson. So the first thing we want to do is we want to look at what the general form of a logarithm is. And the general form of a logarithm is y is equal to a times log base b times the quantity x plus or minus h plus or minus k. Now, something very important I want to highlight is that this is considered a single term. Log base b quantity x plus or minus h is a single term, and it can never be separated. It can never be manipulated. Okay? Now, what are all these other components? Well, the first thing I want to draw your attention to is b. And b stands for the same thing it stood for when we were introduced to exponential functions. It's the base. And it follows the same rules. Okay, b cannot equal 0, it cannot equal 1, and it cannot be less than 0. It follows exactly the same rules. Now, the quantity x plus or minus h is known as the logarithmic number. Okay, it is known as the logarithmic number. And it too has a rule that it can never equal 0 or a negative. So logarithmic functions have this additional rule with the logarithmic number. Now, a, h, and k stand for the same thing they have in everything that we have talked about when it comes to our transformations. So let's highlight those now, all right, and remind ourselves. A, if it's negative, is a reflection across the x-axis. Okay, it's a reflection across the x-axis. If the absolute value of A is between 0 and 1, we have a vertical compression. And if the absolute value of A is greater than 1, we have a vertical stretch. Okay, so that's the first set of transformations. The second set is our h value, and it once again is our horizontal translation. And it follows the same exact rules. If it is negative, it shifts right. If it's positive, it shifts left, opposite of what we expect. And we know K stands for our vertical translation. All right? So if it's positive, it shifts up. And if it's negative, it shifts down. So now that we've identified all the components of logarithms, we are going to focus on what we can do with logarithms today. And the first thing we can do is we can evaluate logarithms on our calculator. Now, what's very important here is that if you were to look on your calculator, you would see a log button. So we need to get comfortable with using our calculator to evaluate logs, all right? And one of the biggest issues is that when you look at your TI-84 calculator, there is a log button located right here next to the 7. All right, to the left of the 7. This log button is programmed to have a base of 10. And a base of 10 is known as the common base. So very often, you're going to see it written like this. Log 7. If there is no base written, it is implied to be log base 10, 7. And then you could use that button on your calculator to solve it. And you would get 0.8451. Now, a key thing about logarithms is you always round to the 4th decimal place. Okay? Now, very, very important. You can only use this button if you have a base of 10, if you have a common log. Only if you have a common log, which once again is a base of 10, which once again will not be written when given the logarithm. So what do we do when our base is something other than 10? Well, let's watch this video together to determine that. All right, so based off of that, you can use your calculator to find any base. All right, so the first one we're going to do together, all right, is the example log base 832. Now, can't use the log button because it has a base of 8. So this is where you're going to use that function explained in the video. And you're going to press alpha window. And I'm going to write this out for you guys. And then you're going to hit the number 5. And now you're going to enter 8 in the small window, which represents the base, and 32 in the argument window, which represents the logarithmic number. And if you were to do that, you would get an answer of 1.6667. I'd like you to do the next two on your own, please. The first example will be log base 5, 125. And the second example will be log base 64, 1/32. So if you plug these into your TI-84 Plus correctly, log base 5, 125 would equal 3. Log base 64 of 1/32 will equal negative 0.8333. Now, in the case that you do not have a graphing calculator that has the capability to change the base from the common log of 10, you could use something known as the change of base formula. And the change of base formula states that if you're asked to evaluate the log base b of x, then you're going to take the common log of x and divide it by the common log of b. The common log of the logarithmic number divided by the common log of the base. And remember, common log always refers to a base of 10. Each of these methods will yield the same answers. Okay, so now that we know how to evaluate logarithms using our calculators, we also want to talk about how to convert logarithmic functions with exponential functions. And the reason we can do this is because they're inverses of each other. So we can convert from one form to the other. And here I have written the basic forms, the general forms of both exponential functions, which we talked about a few class periods ago, and logarithmic functions. So how do we convert between logarithmic and exponential? Well, let's talk about the most basic. And let's talk about y is equal to log base b x. Most basic logarithm. So how would you convert that logarithm into exponential form? Well, the way I explain it is you have the base raised to your answer, and that's going to equal your logarithmic number. Okay? So in this case, our base is b, our answer is y, and it's set equal to our logarithmic number of x. Now, we can expand that if we have log base b x plus h. All right? It's our base raised to our answer is equal to our logarithmic number. Okay? Now, the key thing is in order to convert from the logarithm to an exponential, all right, you must have the logarithmic term isolated. All right? So if we had y is equal to a log base b x minus h, this logarithmic term is not isolated yet. It has the a in front of it. So we would divide by a first and get y over a is equal to log base b x minus h. And now that the logarithmic term is isolated, we can convert. The base raised to the answer equals the logarithmic number. And we can even go further and add h to both sides to isolate the x. So b raised to the y over a plus h equals x. Okay? So let's do this with actual examples. Okay? So let's convert into exponential form. And let's say I gave you log base 10, 100 equals 2. So we identify the base, which is 10. We raise it to the answer, which is 2, and it equals the logarithmic number, which is 100. Okay? Let's try this one. Log base 3, 81 equals 4. The base is 3, being raised to the answer of 4, equaling the logarithmic number 81. Go ahead and do this one on your own. Log base 5, 1/625 equals -4. If you did this correctly, the base raised to the answer equals the logarithmic number. So you want to keep saying that if you have to go in the opposite direction. Convert into logarithmic form. And let's say you had the example 2 to the 4th equals 16, and you were asked to convert that into logarithmic form. Well, you should be saying base raised to the answer equals the logarithmic number. So the base is 2, the logarithmic number is 16, the answer is 4. Okay, let's do 4 to the 5 halves equals 32. So base raised to the answer equals the logarithmic number. So base, logarithmic number, answer. All right, I would like you to do one on your own. Convert 1/2 to the -2 equals 4 into logarithmic form. If we did this one correctly, okay, base raised to the answer equals the logarithmic number. So log base 1/2, 4 equals -2. This is the end of the first video for this section. Please now watch the second video on graphing logarithms.